And so whenever we click prices, we get a new price. It seems to be pretty static, at least at this moment. I thought it would change a little bit quicker, but I don't know how this API works. And also, I've made a point um, to not like dive too deep into this repository. I do have like a good understanding of Obelisk. Um, I actually used to work for the company that produces Obelisk. Um, and but like the key reason why is that I want to show how to problem solve effectively. And I think Haskell is better for that than any other language. Again, part of the goal is to show you why that is, and it ultimately it comes down to the type system. And so if I want to add on to this code, I need to ultimately respect how this code works. I need to. It's important for me to understand something like. I think everyone was here last week. Correct me if I'm wrong. Um, but ultimately I need to know that like this is like connected to the back end and I need to obviously always understand the general behavior of the application before I'm starting. And so what this is doing right now is always just fetching one value for price for Bitcoin, for Ethereum, for World, and for Solana. Um, and so like um, that's my plan. Is I'm going to every single time that this refreshes, the backend will store the the prices that it's fetched, and it will be like a time series data. Um, and yeah, and ultimately also we're going to avoid using databases today just to make things a little bit more straightforward or to cut that out. I don't know if they'll actually make things more straightforward here, but I want to avoid getting into Rhyolite. Um, but I'll just show you guys quickly what I've done here. So I'm going to use get add p to show pieces that I've done. So this is the first thing that I've changed is I went into Nix or my default.nix, and this is like I think this is really cool. I won't go over this too long because this isn't like about Nix. I've added in the reflex DOM echarts library and its dependency echarts JS DOM. So that I could make that line chart that Kyle you were asking about. And so ultimately, all I'm doing is I'm fetching the source code from GitHub directly, and then I'm going to override it in my project. Which if you know Nix, I'll say is like very straightforward, very simple of how I did this, um, and yeah, and the commit will be there in the repository. So I'm just gonna say yes. I also added in containers, which will allow us to use data.map. I added in the actual dependency of reflex DOM echarts and some spaces. I don't know why I did that. I added in type families. Type families because type families is a language extension that I needed for um, my line chart function. I forget why that is exactly. It's not super important, and we'll get into type families and what those are at a much later date. You really don't need to worry about them for now. And ultimately too, by the way, with any language extension that you're going to come across, most of the time the compiler will tell you properly that like you did this, perhaps you wanted to use type families. And so that's what you would do in response. So I'm going to say yes. I added in, this is all just to make the line chart as well. And then this is the actual line chart code here. And so ultimately what this does is forget about everything here. Thankfully I have an Emacs, so I can actually just literally delete all this. I'm also going to delete that. And it allows us to focus on like the key things that matter here. And like this is like one of the really nice things about Haskell is that I can use the type signatures as an interface to understanding my code. Um, and so like I don't need to think about I don't usually need to think about the function body itself, especially if I have a comment, a very oh I think I screwed up somewhere. Yeah, especially if I have like let's say some comment being like this line chart does X, then I should have all the information I need right here in order to figure out what this function does. So what does this function do based on if I was to add a helpful comment, this makes a line chart. This makes a line chart. Line chart with dynamic data is what I would say. And also too, I haven't used this function in a very long time. This is actually, if you go to your profile and you've done like mock interviews in the past, you'll see a line chart with all your different past scores. We plan to change that in the future to update it to like, how you're doing with Haskell or more informative stuff. Um, and sorry, Kyle, can you hear my cat in the background?
No,
Oh,
you're good.
okay. Oh, interesting. Okay. Anyways, um, and so again, what we were saying, let's also just ignore that. At least for now. Oh, um, because we're going to start by looking at the what comes after the type constraints, because that will help us to understand what these type constraints actually mean. These type constraints only like they're acting on the types that we'll see here, and so anyways, the key thing is this: the two key pieces of information is hopefully some comment, which I think goes for any language. You hope there's comments for any function, and that's great practice for you guys. You should always help yourself out in the future when you come back to your own code. Just write a comment. What does this do? And try to be as descriptive as possible. Because you can always figure out how to be more succinct with it later. Is my opinion at least. Um, but anyways, so I can see that this takes a map of text, and a dynamic t um, list of text and int. So that's not super helpful, actually. I'm realizing, and yeah, that's not super helpful. What I'll say is I know that this is sizings based on the name of the variable and dying data, which makes me think that this must be a X label and this must be a Y variable. So in the case of like a mock interview score that's out of 10, this might be like the date is December 21st, and the value that you got was a 9 out of 10 because you're a rock star. And this will return us back a M chart T, or yeah, this will be a chart T in the context of M. And ultimately, that would just be a way for us to interact with the chart that we have written to the DOM. So, anyways, I'm gonna stage that. I don't know what that is. Oh, that's just GHC ID output. Uh, sure. So that's all we've done. We just literally added in a line chart, and I just wanted to show you guys that piece. Also, I think get add p is a very helpful command if you haven't seen it before. Um, and so that's all we are going to do. Just what does everyone think about like that plan? Like, is there anything like you guys would rather see in terms of what we should do for the changes? Because there's quite a few ideas I have in mind, but I'm thinking that's the best idea to do is that we have an added line chart which has we keep our current prices, and then we're going to add in a line chart of the time series prices. All right, that sounds great.
Yeah, I think we can do that, and then we'll try to do that quickly so that we can open up the floor to
Okay.
have people actually ask theory questions. Because I think we've done a lot of practical,
Mhm.
but I want to get everyone here actually writing code.
Totally. Okay, so let's do this then. So I ultimately what I like when I look at this, my first thought is that I should probably keep this all in the same request as at least my first guess. And so how does that request actually work? Um, so how does Obelisk work as a whole? Um, I might not know how Obelisk works as a whole. I do, but let's assume I don't. Um, like there's a number of things I can do in that case. The first thing I want to do, like especially when I'm using a framework, my first thought is to go and check the documentation. And so we could go through the documentation, and ultimately what it would tell us is that this is a Reflex DOM project. Reflex DOM being a front end library, which we see here. Kyle is using this here. Um, it's a Reflex DOM project that is full stack. So that essentially means that we have a config, a comment, and a backend. And Kyle got into that a little bit last time. We also have a static if we want to add images or whatever. But the key thing is that we have a backend. We don't even really necessarily need common so much, except for one key detail, which is the routing. So um, and I'll be honest with you guys. Even like I still have like stuff to learn about Obelisk routing, because it gets quite complex if you want to make it complex. There's a lot of cool things you can do with the encoders, um, but ultimately, that's the key difference that we're adding on here with common is that we have routes. And so I can see that uh, through this information, um, there's two backend routes, one where the backend route is missing, and one where we fetch crypto prices. And I can use this data type, or data constructor rather, in my code in order to say, in order to know that I'm fetching the right URL. And so Kyle did this here. Let me put a pin in that. Um, I'll do a very basic way of use route encoder. If we get to it, and so what this will be is it'll be something that takes, for example, a backend route crypto prices, and it will look like this. This will be my input, because um, as I can see through backend route, and this gets a little bit more complex. If you don't understand this, this is like advanced. Um, but like you know, don't try to work from the examples is what I would say when you get to more complex Haskell, um, and ultimately fall back on this sort of tutorial and others that will provide other help we can provide with like more complex stuff, because this would be an example of um, gadgets or generalized algebraic data types, which is just is really cool, really awesome, but we'll ignore it for now. And so ultimately, this will allow me to write my code back on our crypto prices, and it will turn it into this crypto prices string here. And so Kyle was mentioning last week that um, if, like, for example, we did something stupid and we had a typo here, you know, we would. Sorry, Kyle, do you mind muting yourself while you type? Your
Oops.
keyboard's so loud. Sorry. Um, I know I'm annoying for that. But like if the key difference here and why we want to use a type in general, why we want to use types in general is that we just simply avoid typos. If I said crypto prices as a string, the computer has no idea that's wrong. It can't possibly know that's wrong because you're just telling it it's a string. All the computer can ask is, well, this is a string. Yes. Okay. So like that's as much as I know. Whereas with this, if let's say I said crypto prices here, the compiler would say I have no idea what you're talking about. I've never seen this man in my life. Please correct yourself. And I would just immediately go, oh, I'm stupid. I accidentally put an extra S. Problem solved, and I avoid tons of heartache down the line when I'm you know, chilling, having a great Christmas instead of worrying about a bug in production because I added an S. Um, so yeah, I think that does a good job of explaining obelisk routing. Um, and I haven't looked at this much. I know we did a little bit last week. Um, so how does this work? This is all like new code to me, and ultimately, if there's a lot of new code and I need to understand it at like a deep level, and let's say there's also maybe like libraries I don't know. Like the number one there's one thing I do know, which is the entry point to this application. Um, and well, I guess in this case, I would need to know this by looking at the obelisk documentation. The obelisk documentation would show me that we have this backend function, which has two arguments or two fields. This backend route encoder, our full route encoder, which we'll use to do that here. Let me actually just call it that. Now that we've seen that, um, and a backend, a backend section of routes. I'm going to indent that because I am crazy about indenting that. No good reason. And then okay, I can see there's two like sorry. This is our entry point here. Ultimately, we want to look at the backend run. We know that backend route encoder is very likely not important to what we are trying to do. We know that we are trying to add on time series data, so backend route encoder has nothing to do with that. That's generic to any programming language, regardless of if functional or not. In terms of the problem solving process we're doing here, not the route encoder aspect, but so our entry point here is this serve function, and so ultimately what this is doing is saying here is your series of routes. Based on this series of routes, what should each route do? So I can see that the backend route crypto prices should call the function handle crypto prices. Okay, that tells me where I need to look next. I don't know where crypto prices handle crypto prices is. A joke. It's right here. And maybe I search for it. Maybe I do I search here, and try to find that, or grep to find it, and I find handle crypto prices. I learned something here, in that this is the type snap, snap unit, which may confuse me. Um, does it like? Can anyone guess like why that might be confusing, or is anyone else like confused by that on like why it might be a snap unit? Like
Why is it a snap unit?
why is it a snap unit? Thank you for asking, Kyle. You might guess. So like we returned a list of integers. So my intuition would be that this would be some monad. I would figure that I would guess. Again, I'm playing an act here where I'm pretending I don't know things, and I'm trying to approach it from like a beginner perspective, I'm gonna guess that this is IO because I've learned that like IO is kind of like your go-to monad in Haskell. Um, your main functions are usually of the type IO, um, and so I would think that this would be an IO list of ints, and if not a list of ints, something like an int, like a list of crypto symbol, maybe or I guess looking at crypto symbol now, and this is genuine, crypto symbol as a part of a tuple with an int. So I have information about, you know, what the crypto is and then the current price. That would be my guess. But ultimately, I'm surprised to see that's actually not the case. So, okay, why is that? Um, because that does confuse me. Why? The reason for that is that um, where the information of the crypto symbols and the prices are going, is that they are being used in an effect. So the way that Snap handles requests is that it works by using um, something called a state T monad transformer. And so like it's interesting because even at the beginning of the talk, um, Kyle, we were both jointly saying like there's no state in Haskell, and this is true. But state T is like kind of like the closest like thing that breaks that rule. Um, and you might be wondering like, well, like then how is that any better? Like we're talking about how state is so bad, um, but ultimately the key issue that happens with state is that there's many things that can write to it at any given time. So like if we have like a global state called X, and we're running like two functions, function F and function G, and they have like the program executions, um, or they're running over time is what I'm trying to show here, um, and then like G will output something, and then G will run again, etc., etc. Let's say so these are two concurrent functions we are running, and over time they are affecting X. That we don't know like what the current value of X is. Um, a simple example I actually used to explain this a while ago is um, like let's say you're like programming two robots and they they're both like looking in like the pantry or something like that, and they expect the pantry to be organized in a certain way. So you have your cereal, you have your oatmeal, you have I don't know corn or something like that. Um, and maybe some tomatoes also in a can. And one robot like expects the input to be all of them on the top shelf and will grab from the top shelf. And they're not the Tesla robots that know how to be dynamic and know how to do stuff. They just do exactly what they're told, exactly what they're programmed to do. And so we're programming these robots, um, and they're going to anticipate the um, the tomatoes being on the top shelf, and that works great if that one robot is working all alone and by itself. But and it will go use the tomato sauce, and then or sorry, tomatoes go make tomato sauce, and put the remaining tomatoes back. If there's another robot that's also working with tomatoes, and it happens to place it in a different spot, then the state is corrupted with respect to the other robot. Um, and so like that's why ultimately state is actually bad, is or sorry like global state is bad because it's easy to corrupt and to screw up. It's just it's not impossible to get right. We can have like error handlers or ways that we make sure these robots are going to be correct. Um, but it's a lot easier to not deal with global state um, if we don't have to. And we're not
It,
programming robots here. Yeah.
and it's not just global state, because like a lot of languages, they don't want you to use global state anyways, but like most languages have what's called by reference, or like by reference caching. So
Hmm.
like if you create an object, that object might be by value, but like all of its um, members are essentially just memory references to another object that was created. And most languages actually do this for performance reasons. So it's like a side effect of the language itself.
Mm,
So you can't actually like it's not like you can just be like, I don't want to use global state. Like even if you try not to use global state, it's baked into the language.
right.
Um, and so yeah, like when we say state is bad, we don't mean like every application has to have state, right? Like it has to remember what just happened. But what we're really referring to is like state management, like the way that the state is actually managed by the language itself. And so Haskell being immutable, like the immutability of values is actually baked into the compiler, and there's actually performance benefits to that because it was written in a smart way. Um, but yeah, the state management forces you to handle things in sequence and also to specify the types of the state changes.
Mhm. So like the generic pattern, just by the way, we're not getting into state T here, by the way. But I think with what we were talking about, it's important to talk about. Um, and the mutability aspect that Kyle highlighted, I think lends well to this. Um, so this would ultimately be what we would see. Um, is that like we have this like all uses of state T ultimately follow this pattern of get state, name it, and I think that's like the key difference in my head is like the names and the names are so much a part of immutability. Um, state one is never going to change, right? The variable state one will never change. It will always be the same thing. State will change, like right, our concept of state will change, which is great because we can have changing state, and that helps us to model things. But the actual variable of state one never changes. How do we modify state? Well, we create a new variable called state two, which has that modification. And so ultimately, like even like in a nutshell, funny enough, like you could take this. This is how crypto also works. In a nutshell, is just is like a pure modification from state one to state two. Um, but I think I'm getting way too complex there and way off topic here, even though we are looking at crypto stuff. Um, and and then with our modified state, we're just putting that state back in our state T monad. So we're just storing that state um, to continue on with. And so um, like the reason why state is also better here is that like with state T being a monad, it kind of forces us to have um, to run actions sequentially. So even if like let's say we had um, you know, well, concurrent programs are a different thing, and I used them to illustrate the previous example. But let's say we're in a sequential program where, in a typical object oriented language, you can still have state issues, like we talked about. The only way I could really illustrate them through functional programming easily was through concurrent programming, because that's still a challenge. Um, but for sequential programming, what sequential programming ultimately means is that we're gonna or like execute actions, you know, one after another, or there's like, not necessarily imperatively, where it's like execution step, execution step, execution step. But there is like steps. So there's the concept of steps where this is going to happen, and then this is going to happen, and then this is going to happen. And ultimately, through that, it's impossible to write programs where we aren't sure of what state we are working with, right? Especially um, when we have this pattern of like get state. We might have some like query about state, like trying to figure out something like modify my state might ask something about state one in order to figure out what to do with it. Um, but ultimately, we're never going to be asking, if we have like let's say like modify my state one and modify my state two, we can we can read through a program step by step and know for sure the execution order that happened. So if let's say for example it was one, then two, then two again, then two, then two, then one, then two, and that's just what happened. That's the stack trace of what happened. I promise you that you can go through that code and you will find that clearly demonstrated through the functions. That will be very apparent what the ordering of operations has been. Whereas when you try to introspect with a object-oriented language, this is very hard information to get. Correct me if or where I'm wrong, Kyle. Right?
No, that's correct.
Yeah. So, um, so I think that does justice here. So, what does state T actually mean in this context? State T is our request. So, let's. I know that through my experience with Snap, but let's say we don't know that. I ultimately all I can do if I don't know Snap, or what I would do at least if I don't know Snap, is I would just follow the execution order. And I would also do the same thing in a object-oriented language. To my best efforts, I would try and do that. It's definitely easier in Haskell. But I would say, well, what is this fetch crypto data? That obviously seems important to the overall idea. And okay, I see it's a function down here. Um, and this is going to take in Haskell's really nice for this because if I know my basic Haskell, I can see that this is a function which takes in a crypto symbol and is going to return me an IO action, where that IO action is going to contain the result, or that IO result of an either string list of crypto data. So this is going to, I know from IO, this is going to do some sort of action, some sort of real world action, um, you know, such as probably fetching from the World Wide Web, and if also and well, yeah, no, I'll put a pin in that thought for now, but and that will return me an either string crypto data. And so this works. Like we saw Kyle's demoed it. It works. Um, we get back the right case of this, right? So either, in case you don't remember, is the has two cases um, that we either have left with some error, or we have right with the value we are hoping to find. At least in this case, in the context of error handling and how we use either. Um, so this works. Um, exercise for the readers. Could anyone I'll give you guys like 10 seconds. Um, why? So if this fails, so if this succeeds today, why might this fail in the future? All right, so I think that was roughly 10 seconds. I probably could have counted. That would have helped. But um,
Okay, that's confusing because is it supposed to be fail? Because Haskell.
sorry, pardon me.
I'm saying, is it supposed to fail because it's Haskell? Like,
Yeah, I like the sentiment that it's not supposed to fail because it's Haskell. I mean, we will.
Our application won't fail, but that request could fail,
okay,
is what we're kind of getting
okay,
at.
Yeah.
okay,
So for example, if the CoinGecko API was down, like
yeah,
say, like, because so this is what we're talking about with side effects, right? So there's two kind of things to think about while you're programming in Haskell. I mean, when you're programming in general, there's pure functions and side effects, right? So functions that are pure they don't use IO, for example. IO
yeah,
is the way that we model side effects in a program. So with IO, so the program won't crash, right? Like
okay,
so, but you can still have failures, right? Because
yeah,
a failure just means that something happened that wasn't expected. But what Haskell
yes,
does is it forces us to it forces us to implement the case, like it forces us to think of the what if. Like what if this
yeah,
breaks? We have to have
okay,
some kind of solution. So here we have a left. Um, what might happen if you're programming in like a different language and like all of this is really just to minimize human error,
Mhm.
right? Like you can
yeah,
use any language and you can use any language perfectly, right? So like I could use Python, for example, and if I'm writing Python perfectly, then I'm doing the same thing as Haskell, right? But
oh yeah,
a
okay,
lot of but a lot of a lot of the thing here is it's minimizing human error, right? So and human error, you know, everyone has like a little bit of ego, right? Even
yeah,
myself, we're like, oh, all the code I write works all the time. I just,
yeah,
I think at every line of code, I think, okay, how can this fail? I'm going to add an if statement. Okay, we're good. But
yeah,
human error happens a lot, especially as your team grows, right? So as
yeah,
it's not just you working on the team now. Let's say it's you and five other people working on the team, right? And the way you write your code might be interpreted differently. Like someone else might interpret your code differently, right? And so now they're going to forget about, okay, well, the codology they wrote, it returns 5 when I give it this string. But
yeah,
they don't see that because they haven't read through the entire, like they haven't read your entire function, right? Maybe you just added 1,000 lines of code to the code base because you're awesome and you got like a ton of work done today. Tomorrow someone comes in and they're going to use your code and they might not know about every little change that it can make, right? And so that's
mm,
where the human error comes in, is it's when you're working on a team, even yourself, like maybe you come in a week later and you want to use a function that you wrote a week ago. You might not remember every single thing that it can do. You might not even be aware of every single thing it can do because maybe you're using someone else's function that didn't specify
yeah,
everything
yeah,
that they've
yeah,
done. You know what I mean? So it's
yeah,
it's like if you've ever heard of the game of telephone, where like you say something, like they used to do this in like elementary school a lot, where you would have to tell the person beside you something. You'd have to like whisper in their ear, and then they would whisper what you said into the next person's
yeah,
ear, and then they would like so
okay,
on. The more
they
people that
keep,
you add, by the time it gets back to you, it's like a completely different sentence, right?
yeah,
And so
yeah,
like that's just like a human psychology thing, right? And so that happens a lot in programming, especially as your teams grow.
oh yeah,
And so, that that's how like, and that's why we say like implementing Haskell kind of makes you like a lead developer. Because it's like what you need to do is you need to enforce these rules for your team, right? Like if you need to have everyone on the team playing by the same rules, right? Otherwise, things are just going to break. Um, and
Mhm.
oftentimes this is done through like tests, like different test suites and like um, different PR, saying PR, what is it? Pull request reviews, right? And so like you can review each other's code and you can do all this extra work, which still things slip through the cracks. Or you can use a language which handles that for you, which is what Haskell and other functional programming languages attempt to do. Is it's actually handling those cases. It's forcing you to implement something, and then it's telling you at the type signature level. So like anytime you're looking at a function, you don't want to have to guess what's inside of the function. Like I heard this from someone. It was a really good point. Is like you should never have to read a function to be able to use the function, right? Because that you're never gonna you're never gonna be able to like some of these functions are like 10,000 lines of code. Like even this function, it looks like it's 6 line or like 10 lines of code or whatever, but it's actually like probably a couple hundred or thousand
Yeah.
because t dot unpack, that's probably like 5 lines of code. T dot intercalate, that's probably like five. Actually, it's 1 line of code, but like there's parse request. Parse request is probably like 100 lines of code. HTTP JSON is probably another couple of lines of code, right? So all of these functions, every time you call a function, that's more code that you're adding into your program, right? So, but you should never. Expecting someone to read all of that code to understand what it's going to do and to understand all the side effects, it's nonsense. It's never going to happen, right? And so Haskell forces us to like if I put and you'll see this as you start working with it because like a lot of this it's already written, we've already handled these errors. Like you'll see as you start working with it, it's going to throw an error and you're like, whoa, why is this error happening? And it's because you're doing something that doesn't match the type signature of the function, right? And so like and then with monads, you're sequencing, you're adding something into that sequence that doesn't match the monad structure. Um, and so with these in mind, it makes it impossible to write code that doesn't adhere to the type signature. And so if the type signature is correct and understandable, then you can't have failures. And so here we're saying we have an IO where IO is either a string or an error of crypto data. And so we know that there's going to be a side effect. Some side effect is going to happen because we've said IO. That means it's going outside of this computer and then it's going to come back, or outside of this program and then it's going to come back. And so if we get because we have IO either string, it's going to force us to handle the left and the right case, which you can see at the bottom there.
Yeah.
And so if
Yeah.
it's left, it means it failed. So we have to specify what happens there, which is key. We
And
have to specify failed to fetch data for symbols.
right. And I'll even add onto what you're saying, Kyle, because like love what you're saying. Um, like I think you're the biggest point is like Haskell is like amazing for like the psychology, like the human psychology aspect, which is just like it's the game of telephone. Like that's probably the best analogy I've heard for it. And it just is easier to play telephone. Like it's like imagine like you play telephone, and you said beforehand, okay, there's only 5 words we can use. We can use the words um, dog, rabbit, cat, plant, tree. It's really hard to make a mistake in the translation of that.
I
It
would go even further. Sorry to cut you off. I would say it's like rather than whispering into their ear, you're just writing the note once and passing it around.
That too, yeah, that too. But even like in terms of like the like I'm thinking this example here with the crypto prices,
Hmm.
where we add an extra s or whatever. Um, it's like with whispering in the ear, what happens with like the game of telephone is that like you mishear, because you're trying to like interpret, like you're trying to like decode like the audio of what they just said to you, and so if they say like, dog, like you might be like, do you say bog? Bog, like bog, like the tree or
I
the
think he said
swamp.
frog actually.
Oh yeah, yeah, right. Kyle heard frog, and like I think even like a like psychology fact is like so much of like your hearing is based on top down processing. If you're thinking about frogs at that moment, and then someone says dog to you, you're going to be hearing frog, almost with a large chance of that. Um, so but if we establish those rules that there's only 5 words we can use, it's dog, cat, plant, tree, and then bunny or rabbit. Um, it's like it's much harder for that game of telephone to go wrong because like let's say that the sequence that we have is that specifically dog, cat, rabbit, plant, tree. Um, like the way that you like
Yeah.
the information.
If you hear knee, you're gonna be like, no, it was tree,
Yeah,
not knee. So
and
yeah, it's a bit of
yeah, and
that
so
makes sense.
so the point I'm trying to get to here is we have this crypto data type, we have this crypto symbol here, and these are so helpful. I do lie, that wasn't where I was actually going, but this is now a great next step. Is that like I see this throughout the entire application, and I know like what this is doing. Um, Again, you can also have this in TypeScript, and like encourage you when using TypeScript to be very, very like like using types everywhere, because it just like informs you on like what the heck this is doing. Like that, like this goes from being like think about how much more information is here than a to output. It's like, oh, okay, like what is a? Can a be an int? Can a be and that's what you'll see. Like you'll have like JavaScript functions, right? I hate this so much. Like you'll have people that do like what is it, like I forget the syntax for it. Like some anonymous function, you know, and then like whatever logic inside of it, and like this is the information you have, and like ultimately you have to read this function body to have any sense of what the types are, what the input is and what the output is. I guess you also can see here, but like you'll have like crazy variable names like I and j, and then some sort of logic based on I and j. Um, but here, instead of having like these arbitrary like type name, or sorry, arbitrary names, we have actual types which we can use to have more information about what this name is. So even if Kyle did use the name I here, I can tell a lot better what that is doing, or what this function's doing. And so yeah, and I think this also brings up another interesting point with I/O. Um, so like, and I feel like the language on like monads and I/O gets very mixed together, and I think complicates the heck out of monads unnecessarily. Um, like because most of what we like what people say with like monads, if you go try to find like some random monad tutorial, um, is like they'll be talking about like side effects and effects and all that. Um, most actual like monad instances, like either is a monad technically, maybe is a monad, but they're kind of they're very much pure monads. And IO is the only one that means impure. Um, and um, like impure because we are interacting with the outside world. And yeah, like Kyle said, that we could there's case one, we could have made a mistake with our code, and so this never worked to begin with. But like also let's say that like yeah the API changes down the line, that is going to cause an error at a later point in time. Um, actual example is when you do the onboarding sign up for ACE. We do a check. Like we use OpenAI, ChatGPT, or like the GPT API to check that your name is not offensive. And we model this with either. And so thankfully we model this with either because I guess I must have missed an email or something that the API has changed. And so that caused an error where I had to change the way that we handle our JSON, with or the JSON that we send to OpenAI. But ultimately, all that happened was it just returned a left, and then I basically in the context of the failure with the name. If I like so like ultimately what I know is that I can't tell for sure from OpenAI whether or not this name is offensive. It doesn't make sense in that context to like fail entirely. I shouldn't like say, "Oh, sorry, I can't sign up. I can't tell if this is offensive or not," because like for all I know, let's say it's myself signing up, I might just be typing in like my name is like Galen Sprout, and that's not offensive, and there's no reason that should fail if OpenAI fails, or if my connection with OpenAI fails. Um, but again, it's a very real thing that an API can change. You miss the email, that's going to change, and you want to handle that properly. So yeah, but in this case, in the case of left, we actually do probably want to fail overall because like if we can't get the core user information about what the crypto price is, what are we supposed to do anyways? So we'll just have to tell the user that we couldn't get the data for some reason, and then look into that as soon as possible and fix that bug. And so okay, what are we doing here? So we have this parse request. So Kyle has put in has interpolated a URL here to fetch from the CoinGecko API using a GET request. As I don't think there's no uh, oh okay, I guess you can oh okay, I've never used this function before. I guess this would allow you to have a JSON body, but yeah, ultimately a GET request. So parse request. So this is I think this is like a cool thing about Haskell here. Um, and you'll say like, well, that's actually like not that crazy, but I'll show you like why it is crazy. Is I don't know what the type of this is, so I can do this. Oh, I want to do something here, which is I want to add in scoped type variables. So just like I was saying at the beginning of the lesson, I didn't know I needed this. I don't even honestly know fully why I need this. I have an idea, but not fully. I can get information about this using a typed hole. And so typed holes are really cool. Because, I mean, for me, the biggest reason for it is because I'm too lazy to set my Emacs properly, knowing that I have this typed hole here. But let's say like I haven't I haven't completed my function, and I for some reason I've written like, kind of starting logic. I like what do I do with the input type, and then I have some idea with what the output should look like, and I have this sort of like in between sandwich of like um what should go in what should be in the middle to go between the starting code and the ending code. Um, and I can use type holes for that. I'll try and find a example of that. Or
Just Galen, just quick time check. We got 30 minutes left. So
okay. I don't know if I'll actually do the. I think I'll do something
Yeah,
instead of
don't
the.
let's like I'm thinking like because I just had a really good conversation with Sarah um about just like how to read type signatures. Like
Cool.
I feel like we haven't like I feel like we should really almost take a step back here
Yeah.
and like let's just let's
Yeah.
get some questions going about like the actual code and syntax that you see here, right?
Totally.
Because like we can implement the line chart, but like it's just going to be adding a bunch of code that you've never seen before.
You're right. You're right.
So
Yeah.
I think yeah, maybe Olajide, Sarah, if you have any more or any other questions, any further questions, if you want to just like we can like scroll through the code and you can be like, what is this? What is this? Why is this? Like I think that's probably going to be the best use of our time right now.
Totally. Totally. Yeah. No. Yeah. Definitely. So, um, okay. Yeah. And I think this also like lends really well to what I'm talking about with typed holes. Um, and a better example of where I could use a typed hole is actually like let's say I don't have this. And so this will actually cause an error. Um, because it can't figure out what it is. But if I want to, I think this will work. Yes, okay, I can see. Um, I can use this type hole to get information about the how these two type signatures mix together. So I could look up, for example, HTTP JSON in isolation. I could look up request in isolation, um, or rather the type of HTTP JSON or the type of request in isolation, or the type of try in isolation. But like here, I genuinely have no idea. Um, I'm not gonna lie, I do. And as you get really comfortable with Haskell, like it no type signature is too crazy to understand. It actually is super approachable, no matter how complex it gets. But here, like this does get quite complex in terms of how they combine. Um, and I don't understand what this will give me back. So maybe I've looked into some documentation. And I know, pardon me. I know that I want to use an HTTP JSON, um, and on my request, and I know that I want to to check if it succeeds or not. Um, but I don't know what the ultimate type of that will be. So this typed hole ultimately does that calculation for me. Um, and in the context of like a type, or sorry, a code editor, you wouldn't be able to do that. You wouldn't be able to like scroll over result, and um, to my understanding, like do that sort of calculation.
Yeah, you can.
Oh, you can. Okay, well then I'm an
Haskell
idiot.
language server does.
Never mind.
Yeah. This is good to showcase that like you can basically you can with the typed hole that Galen keeps referring to is the underscore after the two colons. And so if you like you can see above it how it's just request takes the little arrow. But here you can add like it's just like a quick way if you don't have for whatever reason Haskell language server is hard to get set up. None of us have ever actually gotten it set up. Um, so that can be maybe for your task for the holidays is if you can get Haskell language server set up, then you can show us how to do it. Um, but an easy way
I
to
sorry. It well, like
it
I think it's
doesn't work. It doesn't work nicely on Windows Subsystem for Linux. That's the only problem.
okay. Fair enough. Fair
Yeah.
enough. I don't know that. Yeah.
So result it has something to do with the binding between the Windows and the Linux. Um,
Well, I
so
think for me, I use Ubuntu.
Ubuntu, yeah. So you should be fine.
Yeah,
Yeah.
yeah.
Mhm.
So
I mean Windows, and then I have Ubuntu
yeah,
installed on it.
yeah. So give it a shot. I know VS Code has an extension for Windows Subsystem for Linux. You might have to install something called GHCUP to get that working. But if you can't get that working, there is a very simple way to check the type of whatever function that you're trying to run, and that's just using this typed whole concept. And what you're basically doing is you're creating an error. So here we're saying result colon colon underscore, and we're basic like in Haskell you should there needs to always be a type. So by putting an underscore there, you can see in the error it's saying found type wildcard underscore, standing for either EO or E0 response value. So it's kind of like a hack to tell you what the type of the function is,
Yep.
right? So this tells you that by putting a try HTTP JSON request together, it gives us either E0 response value. So
And
Haskell language server can tell you that. Like if you were to hover over result, it would tell you that. But this is another way of doing it. And really, that's probably what Haskell language server is doing under the hood.
ultimately too, I think like for me, like the reason I haven't moved away from this is like the psychology aspect of it. Like I almost feel overwhelmed in when I use VS Code and I can like hover over something, or I'll like hover over something and then learn about the type of it, or like it'll just be like a lot of information. Whereas I like pure focus on like the next thing that I'm doing.
Yeah,
Um,
that's fair too.
so I think that's why. Um, but yeah, like and actually even from this type wildcard, I am genuinely learning about this function here. It was ultimately in this, I guess, um, but I can see that I think value, I believe, comes from. Um, actually, let me do something here. Let me. Let's do ob REPL. Actually, I'm going to do ob REPL non-verbose, just to hide stuff. Um, but what I can tell from this is that this is like returning the response as JSON. So this makes me curious, like to learn more about the types that are at play here. Um, so the first thing I would probably do is I would look at request, see like what's the type of this. Okay, this comes from network HTTP client types request. Um, and if I go to Google, I think I can literally just copy paste this. Oh, what about if I do that? Okay, from HTTP client, and I can learn about the type that is at play here by just copying and pasting it into Google. And I also want to learn about this HTTP JSON. So I just hit the S key to search through this package, and I can look for HTTP JSON. Oh, where does that come from? Okay, actually, I thought that would come from that package, but it does not. This is from network.http simple. Gotcha. Okay, so HTTP simple. I haven't used this in a while, but I know that this is a simple interface on top of network HTTP client. And so what does this do? I see that it takes a request and returns a response. Okay, makes sense. Perform an HTTP request and parse the body as JSON. In the event of a JSON parse error, a JSON exception runtime error will be thrown. Um, okay. I'm not sure I like that, to be honest, because I do see that it does like throw a runtime error by choice, which is interesting. It does happen. Um, but there are functions we can do to decode the body ourselves.
Oh, we should be using HTTP JSON either.
Oh, HTTP JSON either. Oh, cool. So you know what? I'm going to actually.
Yeah.
I'm going to do that.
I was being a bad boy. I actually didn't know that, so
All good.
always
Uh,
be careful when using functions that you didn't write.
so I am making my first changes to Kyle's repository, and I'm excited. And so now this will change into a well, the type of this. I'm actually going to use my type hole again. Um, okay, so it's still either response value. Uh, I guess then,
It should be fine then, right? Should be the
yeah.
same.
I guess I can
Yeah.
have a left. Just because complex. So okay, I have
Oh no, right, because the right is a response value.
yeah. I intuitively know that the response value instead of it being an A. Oh, so this would be here. Okay, so this. Okay, so I have an either some exception from the API being wrong, for example. But if that succeeds, then I have another either, which either has the JSON exception or my A, which is, I guess, a value. What is a value? Um, Actually, I wonder if Kyle at the top here. Kyle is nice, and he has made his code very readable. He has imported it directly, so I can see this from data.ason. Um, what is data.ason? It is our JSON library in Haskell. So this is like an awesome implementation of JSON. It's quite nice to work with. It's also very easy to work with. I literally just need to say that this is something that can turn into JSON for a lot of things. Actually, for everything. For everything, I could literally just say, "Yep, this can do JSON," and
Yeah,
it
it
works.
automatically converts your records into JSON objects, which is nice.
Hmm. So, um, yeah, and it does that through some Haskell trickery, which we will not get into. But ultimately, I don't even know that Haskell trickery. I just know it's complex, and I don't ever need to worry about it. I don't even ever need to care about it unless I want to change how the library, I guess, it works. But I know that the library works, um, so why would I care at this moment? Um, so this response. So how's this going to change? So I'm just going to like add on here. This would be a right of either left, JSON exception. And I don't know what I want to do there yet, so I'll just put that for now. Or right of, I guess, right response. And I will probably do the same thing. I'm going to try that. I guess I'll say return left. And yeah, that's not valid. um, okay, I still have my typed hole in here. Not in scope, HTTP JSON either. It tells me perhaps you want to add HTTP JSON either. And I meant to say this before, but like when I see an error in JavaScript, I do want to scream. I genuinely do want to scream. And a lot of the times, like the reason why I want to scream is because a lot of the times it's like not a helpful error. It doesn't actually like tell me directly what has gone wrong, because it really doesn't have the mechanics to do so built into the language. And ultimately, that means I have probably a couple hours of debugging to do. And I have no idea why I have to do that debugging. With Haskell, like the errors are your friends. Like you really are like you never have that case where you're doing 2 hours of debugging because it's not compiling. Like that any of the compiler errors are so like I'm trying to think of a case that invalidates this statement, but it's always
Once I'll add the caveat once you know how to read them,
yeah, that's fair. That's fair.
because
That's
I think
fair.
there's until I learned how to read what was it, the the one for type signatures, or not, yeah, for type constraints, which like we'll make sure that we just like get that right off the bat, because it's really easy to understand once you, but like for the longest time, for whatever reason, I was just like, what is this trying to say to me? um but once you know, like, just like this is where you look, then it's actually really easy.
Hmm.
Like I think the point that Galen's making is extremely valid, that it's like the error messages are actually descriptive.
Yeah.
Like in JavaScript, usually it'll just kind of say like index out of bounds, and you're like, okay, but why is the index out of bounds? Or, like there'll be like some random error, whereas this actually tells you specifically, and because it's so specific, um, and it gives you a lot of information, sometimes it might be overwhelming, but like I'd say like as soon as you solve an error once, the next time you see it, you'll know exactly what's wrong.
Yeah. And also too I think the what needs to be said about like error messages is like I think it's very easy when you're just starting out to just like be like and want to freak out with seeing them, which I know I just said I do. The truth is I do still hate to see an error, but even if I'm in JavaScript, the best thing I can possibly do is very straightforward. I have the error message in front of me, and although it's intimidating, although there's so much information here, or with a JavaScript error, the best thing, the next best thing I can do, or the next best step that I can take, is to just read that error and make sure that I understand it as best as I possibly can. And so I think that's what we should do next here, because this is your most common error that you will have in Haskell. I'm going to just make this a little bit like nicer here. Um, so can't match expected with actual. So what does this mean? So let's say, for example, I have a function f which takes an int and prints it to the screen. So it's going to just oh my gosh, sorry, my cat is going crazy. Can you hear Cookie in the background, Kyle?
No, you're good.
Okay. I'll just.
Cookie wants some cookies.
He wants the plants beside me too. um. So. Thank you. Um. F is expecting an int, right? Like, so if the error that I would see here, let's say I said that this takes a unit. Like I'm gonna give it just nothing, right? As a unit. Um,
Oh, sorry, I'm typing.
it's all good. Sorry. You can probably tell by my face. Um, um, if I give it a unit, I'm gonna get this error. It's gonna say can't match expected int with actual unit. And that's the key information that we see here, is can't match expected int with actual unit. And all that's saying is that like put it another way is like you're not following the type signature. Like you're giving it something that it's not like meant to handle. Um, and the compiler knows that and can tell you that information. Again, conversely to or
So
inversely to what? Sorry.
I want to add something here because I think this is a good, maybe even a good question to ask. Is because we see here we have either A0, B0. Those are in what? Lowercase values, lowercase
Yeah.
types, right?
Right.
And then we have above, we have response either network HTTP simple dot JSON execution A2. So I've just put out the question, what do we think, like how do we think that we need to solve, like what would we do to solve this? Why is it not, like which part specifically? And that's for either Olajide or Sarah. Just a quick question. If you have no idea, just that's totally fine. But
Right, and this is at 107. So this yeah, this is still valid. Let me make sure. So 107.
okay.
Um,
So the reason is that one is wrapped in a response monad. That's a monad, right? I believe so.
yes.
Yes. So one is wrapped in a response monad, the other one isn't. The fact that the network HTTP simple JSON exception, this is an implementation of the A0 polymorphic type. So either A0, B0, since those are lowercase, that means it's polymorphic. It means it can be any type. It doesn't, unless it's constrained by the type constraints, but it'll tell you that after. So we have the correct type inside of the response monad, if we notice that, right? Oh no, sorry, it's expecting response. So it's other way around. It's expecting to have it inside of a response monad, but we're just giving it the either.
Um, well,
So we need to turn that into a response is essentially what that's saying.
sorry, let me just check something here. Um, oh, sorry, I think it might be because I took that out. Okay, sorry, that might even also be it. Let me just check here. Okay, that's a little bit more helpful. So what I'll say too, everything we said there is valid. Um, try does get a little bit more complex because try is a very like it can is a highly polymorphic type, and so it needs to, like, this is ultimately telling it what sort of exception to look for. And so we can specify any type of exception, and try will figure out how to make that work. Um, but yeah, and so in this case, what do we have here? We have expected versus actual. And I just want to line this up. So I find visually this helps me to figure out what is the difference here. Um, so this is just saying that it was expecting an IO at 102. Oh, okay, so it's a different line. At 102, Oh, yes, because this is no longer valid. I'm saying that this is a response value, whereas this is actually a response either JSON exception value. Let me make sure my brackets line up here. And so that was the actual issue that we were having right there. And so how did I figure that out? The information that I have here, the first thing I always look for is, of course, what is the line number? And in Haskell, it's always accurate. There's never like a case where like it's actually on a different line or something like that, which I have seen with JavaScript. Um, and what I'm doing on 102 is I saw that I am specifying the type signature in order to specify the type of the exception. Um, but and I can do this sort of like type annotation anywhere. It's not necessarily because of the I need to do it here because of the exception. But like let's say I did this in another context, the same truths here are still valid. Um, I have I had said that it's a response value, and um, right so I'm telling it to expect a response value, or I was telling it to expect a response value. Um, but what's actually true is that based on this type signature, the compiler knows better than I do. Right, that's the like, and this is also why type errors are your friend, and errors are your friend in Haskell. Is the compiler absolutely knows better than you do, 100% of the time. Um, you know, uh, it just does. And so like listen to it, like try to soak in what it's saying, and ultimately it told me how to fix my code, and all I had to do to fix my code was say, um, change from value, right, where I have value here. The difference was that it's actually this here, and I believe. Oh, and there's a further thing that this will be a value. It doesn't know for sure that it will be a value here based on the type signature, but I know that it'll be a value. So I can use this information to figure out how to correct my code based on the type signature, or based on the type error. So, oh, yeah, that's not valid. Not in scope. Okay, so I want to add this to network HTTP simple. So it comes from there, and I'm just gonna add it as a thing. Um, and then at 106. Okay, this is confusing me, and I'm not sure why this is happening. Um, oh, right, because no, that doesn't make sense. Sorry, I can see upon review from my types that what I'm saying here is nonsensical. Let me just make sure. Oh wow, my audio is very low. Um,
It's clipping now. It's like way too loud.
oh really? Okay. What about now?
That's good.
Okay. So I can see from my type signature here that this makes no sense. I'm trying to pattern match on this. So I'm correct to start with this either, because the one of the types, or sorry, one of the cases of either is right or left. So I would pattern match on one of those cases. So far we are correct here, but I had thought, I just assumed that the next thing would be the either. But before we can unwrap that either, we are in this response. So I actually don't know. Okay, so I guess this is nonsensical. I'll leave that there for now. And this will be a right response. Get response body. Oh, you know what? Okay, so how I can fix this code or update this code to what I'm doing is I can use fmap to I think I can use fmap to get around this. Get response body. What is the type of get response body? Oh, this is going to be an either. Okay, let's just try this here. You know, and I'm thinking too far ahead. Let me even just follow the type signatures, or sorry, the usually instead what I'll actually do is just follow the type signatures, sorry, the type errors until it is at least somewhat working again. On 110, it's trying to. Okay, so I guess I'm gonna rewrite this. The type of body is either JSON exception value, and parse CoinGecko response crypto symbols body. Oh yeah, this is actually straightforward. So the issue now, and let's derive this from what the types error is saying. If we look at the type of parse CoinGecko response, it's saying that it's looking for a value here. But what I actually have is, I'm just going to do a little comment here, either JSON, either, some error. I don't care what the error is, so I'm not even going to say it here, but we know that it is a JSON exception for what that's worth. But it doesn't matter because I can ignore it using fmap. So how do I actually do that? I can say, I can fmap the function of parse CoinGecko response crypto symbols. Sorry, I'm gonna let my cat in. He's being very loud. 1 second. The issue with cats.
So yeah, we are just a time check. We are coming up to the end of the 12. Like we can go a little bit later if you want, but also like we should try to wrap it up. If anyone has questions about like what they wanted, what should you do next? I think that's a good time. Galen will just fix this function up, but like ultimately, if you guys have any questions about where to go next, I think that's most important because like ultimately we want you to get through those projects, and by the time you finish those 4 projects, like I think you'll be in a good spot where we can start to advocate for some of the job postings that come in, right? So those projects are ultimately like what will get you they're ultimately what will get you into a job because we'll actually be able to understand like we'll actually be able to judge whether you have a good understanding or not, and we'll be doing basically like mock interviews with you on the projects that you've done. Like we'll ask you to walk us through how you solve certain problems, these kinds of things, which will be really good for helping you actually get a job. So ultimately, the goal is to try to get started on projects. And then we're also going to have more projects that'll help you like specialize in certain areas. Right now we just have the 4, but that should be plenty to get started. So yeah, if there's anything that you need to get going on those, either ask now or reach out to us in private. But that's ultimately the goal of these sessions, is to help you with those projects.
Mhm.
So I'll just leave it there, and then if you guys have to leave, that's fine. But Galen will just continue
Yeah,
with this.
and yeah, Kyle, I can't see the chat, but if anyone asks questions, button at any time. And
Oh,
yeah,
I've been answering lots of questions in the chat, so
cool, cool,
I
cool.
think we're good.
All right. So what I'm trying to do now is I'm trying to basically like retrofit this to now using HTTP JSON either because I'm trying to make this code better, right? I definitely don't need that anymore. Um, and so the last thing that we did there was we saw that we need to get around the either JSON, um, the either type, and so we can fmap that on top of um, we can fmap parse CoinGecko response over the either. So parse CoinGecko response, and this is another like good use of type holes here, is I'm just gonna bring this up. Oh, this is gonna complain for a second. Um, okay, well if I thought type holes might bring it up really quickly or whatever, but I guess it's saying there's an error before we get to that point. The stop. My cat is eating plants. Um, if we were to look at this type signature here, it would be um, already partially applied. So this would already have taken in the crypto symbol. And now this would be of the type value to either string crypto data. And ultimately, the output here does not matter whatsoever in terms of our use of fmap. But what does matter is that this body is of the type either error A, and we want to ignore this side here. And so, in order to do that, we can use the functor instance of either to ignore either itself, and just apply something to the A directly. So we can ignore the wrapper and just go right to the actual candy inside. And so I'll get rid of that. And I think that's actually I'll keep that because that's valid. It'll tell me if I'm wrong. And oh yeah, it's gonna complain about something here too now. So I started by I thought this was a pure function, although I'm not. Or where is this complaining actually? I should check that first. Oh, this is complaining. Right, this is complaining because I am not giving back the value that this function expects. So I guess I'm changing the code. I could, in theory, maybe in some cases it makes sense to change the type signature here to update to what I am doing here. Or in this case, it makes sense to try and force my types into that box where it will continue to return an either string list of crypto data. And so how do I do that is I can pattern match on the case I the crypto data, and let me just do this. Let me just make sure that actually works properly. Oh, and it's still going to complain because I have this after. So if I remove that, this is working, even though it's undefined so far. Um, and I will have I have to pattern match now on an either um, crypto data. So how do I do that? I want to look at left. Okay, let's actually annotate this, and I'm going to use the type signature, or sorry, I'm going to use the compiler to annotate it for me and to document this a little bit better. So this is an either JSON exception, either string of crypto data. So how do I pattern match on that? I want to first do left of the JSON exception. And so if I'm in the left case, there's no more data to unpack. It's just simply the JSON exception itself. And so I can say whatever there. I'm not going to deal with that case yet. I'm going to focus on the patterns. The other cases that I have right, the correct case, so I didn't have a JSON exception, but something failed with this parse CoinGecko response. So I had a different parse error according to this parse CoinGecko response, which I have no idea how this works, and I'm going to avoid thinking about it. But all I need to know is that it's possible to fail in this context. And it's already giving me back the error, so ultimately I don't even need to think about what to do with the error in this case. I'm probably just going to give back the same error. And then lastly, we have our success case, which is write crypto data. And so given that we are in a pure function and we have this type signature, what would be the type of these three cases? All three cases must be IO either string crypto data. Right? Every single one must be of the type either string crypto data. And so now I need to fit my types into that box. So this is kind of simple in this last success case. I'm just going to say pure, or I'll use return. Return and pure are the same thing, and we'll get into that later. Return write crypto data. And so now my success case is handled. Oh, sorry. In the case of this, I am going to just simply return the error. And the only other case that kind of like the added complexity here from what I have, added in by using HTTP JSON either is that I now have this JSON exception. So I'm going to be lazy here. All I'm going to do is I'm just going to pack it. Or sorry, to show it, I mean. So I'm going to say left show JSON exception. And why does this work? Does anyone have any guesses as to why this works? Or why I can do this? So the reason for this, and I'll just go quickly here. Actually, I also have my REPL here. And I can look at what is the type of show. And show takes anything with a show instance and returns a string. So this now begs the next question, which I could just try this and see if my compiler throws an error, or I can say, give me information about JSON exception. Oh, and it's not in scope because I haven't imported it yet, but I can go look up the type on Google just as easily, and I will find that it has an instance of show. So this means that I can turn this JSON exception into just a normal string. And so I'm going to do that, and then ultimately I have not disobeyed the rules of the compiler, and my code works. Yeah, and so you know, I'm not going to show the front end because the front end isn't different at all. Ultimately, all we did here was we made sure that this handled another case of if the CoinGecko API gave us back an invalid JSON. And in that case, we now handle that and then show back to the user the JSON exception. And
Cool.
yeah.
So that was kind of a little bit of a lesson on how to approach an error.
Right.
I think that was a good.
Exactly. Yeah. And
so we're a little over time.
Yeah.
Olajide, do you have any last questions or?
No, I'm good for now. This has been very,
All right, cool.
very.
The last thing I do want to add, just for the sake of completeness, because it's not too much out of reach, is that like with the result of this function, we're just gonna ultimately just write the JSON, write the response body, like yeah, we're just gonna write a byte string to the response body. That's it. That's all. So yeah. Or sorry, I'm looking at the wrong case. We are literally just writing a JSON response with the value that we got back from here. So if we get crypto data, we're just writing it as JSON to the response body, and then the front end is going to get that data and parse that JSON and do display. So yeah.
Yeah, sorry. I just wanted you guys' opinion on this. So, what do you guys think about custom data types in Haskell?
Custom data types. You should use them everywhere.
Yeah.
If I know what you're talking about, like you mean like the data syntax?
Yeah.
Yeah. You want to use those like everywhere. So that comes into domain-driven design. Galen, I don't know if you want. Can you show an example of like where you've done some domain-driven design with data types?
Yeah.
I don't know if you want to show if you have like a side project, or I don't know if you want to show A stuff,
I don't
but
care about showing Ace. I mean,
yeah,
it's not
like
going to be.
it's like what? Yeah, without the repo, they're not gonna be able to reproduce it anyways.
Hmm.
Just going through your types, even, yeah,
Yeah. So
like it's used everywhere.
Yeah. So I have a payment form, which just ensures that I get when we send a request to the back end that we have all the appropriate information. It's also using records. It's also a record data type. So when I'm working with it, I can let's say if X is of the type like payment form private, then I can say payment form discount code on X, and that will be of the type maybe t.text. And so it's just like a very, let me call this something better, like form or whatever.
Yeah, and the one below it I think is even a better example, because like here you could have like right now you have text and int. I'm assuming you probably have some kind of like smart constructor for that, but if you look at profile data, the job stream and seniority types, those are also data types that were
Oh,
customly defined, right?
totally.
So if you can you go to what job stream is? I'm not sure what that is.
Yeah, let me keep that in the forefront there. And and then yeah, job stream. So when you do the onboarding form, you enter in you there's a drop down that's selected, um, and you'll see options like I want to be a full stack engineer, I want to be a front end engineer, I'm a back end engineer, et cetera, et cetera. Um, and on the front end, that immediately gets converted to this job stream type, um, and then that is part of the onboarding form, which is then sent to the back end, and stored. So
Yeah.
ultimately, like if I want to make sure that all of my logic around job streams, like the questions that you get for a mock interview are based on your job stream. So if I want to make sure that um, you know the logic for that is valid across the board, it really helps to have this custom data type, because um, I know that I've handled it properly to start with, which means that it's it's valid throughout the rest of the application. Um,
Yeah, exactly. And so that's kind of one of the benefits of like I'll say any program that I write, this is where I start, is by defining all of the types, all of these data types. Um, so these are, it's like I would say this is like the backbone of Haskell is what you're seeing here. Like this
mhm.
is
Yeah,
like getting really good at define. Like you can actually pretty much write almost your whole application with just types,
yeah,
like pretty well, and then all you're doing is defining like the transitions between those types.
and
Um,
I think the key thing about types too is like you could do this, like you could, again, you can do anything in Haskell. Anything you can do in Haskell, you can do in any language. You could, define like a system that's like, okay, these strings are like a job stream or whatever. Um, but the key thing is that like with types, it just allows building on top of that to be easier. So like like I can have a function that's then like choose questions, and I know that I can like pass in a job stream, and that I don't need to worry about where that job stream is coming from.
it'll also the compiler will pattern match on all of those options. So uh, I've actually been playing around with this a bit, Galen. And in other languages, you can't do this without throwing an exception somewhere,
Yeah.
because even with an enumeration, there's always the default case where it's neither of them. So like if you have a string, right, and you've got an enumeration to determine like what string you want it to be, you always have to specify what the default case is. And normally all your only option there is to throw an exception. Um, and so this, like, there's a big difference because enumerations are handled at runtime. Like if I'm in like C# or Python and I create an enum, like enum,
Mhm.
if I create an enum, then all of the checking of those values is done at runtime. And so there's always the possibility that it's neither of those. Like you can just set it, like if you have an enumeration, all it's doing is it's setting it to an integer. So like if I have an enum with 5 values on the back end, like underneath the hood in a language like Python or C# or whatever, all it's doing is it's assigning a label to an integer.
Right.
So you can still say like enum. So let's say there's 5 values, you could still set it to 7,
Yeah.
and it won't complain because it's an integer. Like the type system is only able to understand that it's an integer. It's not able to understand that it has to be either 0, 1, 2, 3, or 4. Um, so the big difference between something like this discriminated union or this sum type on the left side, the job stream, is that all of these options are accounted for at compile time. And so you can't provide this function anything other than one of those labels. And that's done at compile time. You can't do that at runtime.
Hmm.
Or you can't do that at compile time in other languages.
Right. Yeah. I know I was working on a project in TypeScript where it was yeah like it got to the point of like why am I even trying to use types?
Yeah.
Because like yeah it would just turn it into like a it would turn my enum into a number, and it was like, and then I had to have a system to go from number to back to the enum.
And then if it's not the right value, you have to throw an error.
Right.
So it's like
Yeah.
why am I even trying, right? So it's the big difference between compile time and runtime.
Yeah.
Like once that really clicks in your head, you're like, okay, this is why we use functional
Right.
programming.
Right.
Yeah.
Totally. And like I think like even
I think Olajide, do you have something to say? You're unmuted.
No,
We can
no,
talk.
I'm just acknowledging what you guys are saying because it's been really helpful. Yeah.
Okay, awesome. Yeah.
sweet.
Yeah.
And yeah, like we use this all over the place. Like, so if you also like let's say you do a a game on or like they're more like exercises than I like to call them games because it sounds more fun, but they're not that fun. I'll admit that. Like if you go to the pre-interview exercises, I have a generic interface that like runs those games, like selects like what page to do next, and when you get to the end of those games, sends a message that Olajide has finished the game skills inventory, and again just another like enum. Yeah, enum is the workhorse of like typed languages, um, like properly typed languages, like actual real enum, like we're talking about, um, because like yeah, we know the full set of possibilities, and we know therefore how to match on the full set of possibilities, and so if we know how to match on the full set of possibilities, we can then have code which follows, which handles like for each case handles that case properly. Um, and if we can handle each case properly, then we can handle every single case properly, kind of thing. Um, so yeah, it's another one. Like I have like I think there's another like um another another case like a different example is um and I'll admit this is a bit of a hack. So I'll be honest, most of these like I'm different from Kyle in that I'll just start writing stuff. I'll say like here's the logic I want to do, and then I'll ultimately think of the type second. But the way that I do that is like let's say like my function starts out as like f from text to text or something very general, or from string to string. Um, what the next step I'll do is I'll say that okay, type string or sorry, type email equals string. Um, and then update this so that it says okay, this is an email, and this returns an email. Maybe like I don't know. Maybe this is like validating the email that it's a proper email. I don't know why I need IO for that. So let me just make this more applicable. Um, and my type error equals a string as well, which is at least a lot more informative than either string. And then the next thing that that allows me to do is it allows me to over time make my code better. So let's say I want to, let's say I've used email and error in like 50 different places in my code. I've really set myself up for success here, because even though I've been lazy in my types, all I need to do is I need to say new type email equals email on email string, and whatever you can see I'm also doing other stuff here, but um, so if once I make this change, like the compiler is 1,000,000,000% my friend, because it's gonna say you need to change these 50 different places. Um, like it instead, like, whereas like in JavaScript or like another language, it has no idea that um, those pieces of code are now wrong from a change you've made. And this is like one example. Um, but
Yeah, I think that's a good place to leave it. Is like all of this allows you to like the compiler literally knows if a change that you made broke other parts of your code,
mm-hmm.
right? Because you've specified these are all the possibilities. If I add a new one, it's going to say not all patterns have been matched. Please add some implementation for this pattern.
Right.
So I do have to actually go to Galen at 12:30. So
Okay,
if we want to just wrap it up here.
that's fair. That's fair. Yeah. OG, any last questions or?
No, I do not have any other
Okay,
questions. Thank you
of
guys
course.
very much.
Yeah, awesome.
And we're always available. So if you ever have
Yeah,
questions later, like it doesn't matter if you ask questions now or later. So,
Yes.
yeah.
yeah. Like if you and like the our chat on Ace Talent, it
Yeah.
supports Markdown, so you can just send us code examples and like we'll help you out with that.
Yeah.
Mm-hmm.
Okay.
All right, awesome. Well, have a great rest of your year. I think the next lesson will be in the new year, so it'll be 2025 on January 4th.
Mm.
So